everybody. Got a lot of questions about the 148 and the display and all that kind of stuff. So about a dozen or so emails about this actually. So there's the radio, and we got the OLED installed, got the encoder, all that done. It's just on a proto board stuffed in the back. Need to get a real board whipped up in an Eagle for that. I do have this whipped up in Eagle, and I've even sent Gerbers off to a board house just to get them checked out and get an estimate and all that kind of stuff, you know, quote. And so I'll probably get 5 of those run for a very low price because it's small boards. It's very cheap. You know, these days, you know, you can get small boards made on the cheap. Double-sided, you know, no more than that required for this. So, you know, no through holes. All quad flat packs and SOICs and things like that. So, you know, all surface mount. And so there's the display. The OLED works very well in the car. This particular radio has been living in my car for about 2 weeks, and it just works. I can read the display easy. I can go through all 120 channels, just flip the knob, and I can go through the entire range. I've got my one memory push button on the encoder. Absolutely works a treat, no problem. I'm very happy with how the OLED works. I thought that this was going to be a problem. I really did. I thought, was certain it would be a waste of time, that this just was not going to be legible in the car, daylight, and all that kind of stuff. So it just seemed to really just work out. So I brought it in, so I'm going to take out this blue LED. I put this blue LED in for kicks. It doesn't work very well on the S meter. You can't read the S meter with this in here. So you know, I see people doing it and they're like, oh, it looks cool, and it does look good, but it takes away the functionality of it. So it's sort of like iPhones, function or form over function, I guess. You know, a lot of people would argue that iPhones are form over function. So you know, I don't want to get into that discussion, but you know, if this has no real use once you just go ahead and color it, because now you can't read the plate behind it, it really, to me, it's useless. So I'm going to put a white LED in it and move on. I tried it, I didn't like it. So that's pretty much all there is to it. So I've got to get probably some real boards made and put those in radios and see how it works out. It shouldn't really change, but you never know. That said, also going to change the encoder. I got some new encoders, just for illustration. This is one of the ones that I've got tons of these laying around here. These are really cheap, you know, one hung low encoders, and you can see the slap in the indent there, just how wobbly that is. That's within the indent, just going from one side to the other. That's turning it, that's going to the next indent, and so on and so forth, and that's the next one, and the next one. But you can see how much wobble there is in that control. Not when you push it, but when you try to turn it. And it will actually, depending on where you are on the controls, and all of them seem to have this flaw, depending on which one of them you're on, and you rock it like that, it'll actually register a change. It's very bad. Same with this one, because it has the same encoder in it, and the wobble in that, same wobble. And if you have it in the right place, it will actually register a change. But for the most part, I've worked that out of it with a lot of debounce, because it only seems like one pin will change and not the other, because usually they're out just 90 degrees out. So you know, you can debounce that, but we have now our new ones, and try to show this without it having it mounted to something. So I don't know how well this is going to be visible on the camera, but yeah, the whole body of the whole control wants to move. There's no real play in that at all. The whole control wants to move. I can't really hold on to that, you know, without moving the whole thing. So there's very little play in that. So much better encoders. These are like a quarter, and these are like $1.75. So you know there is definitely a difference. So these also have a longer shaft on them than these do, because that's really the reason I wanted new encoders, is because I needed these need. Some radios need a slightly longer shaft, for, you know, mounting reasons. They don't protrude through the faceplate. This one does for the 148. Okay, it is a little close, but not enough to touch the radio. It does almost touch if you push the button, and that's of course the issue. You don't want to push the button. If you pushed, and like with this one, there's a, you know, a push and a rotate. So if you push it in and you rotate it, you don't want the control to hit the faceplate of the radio. You want to be able to push it and rotate it freely without it rubbing and scraping or anything like that. And on this radio, it will do that because it's pretty close. So with an extra 5mm shaft length, that's no longer an issue. So I'm going to swap the encoder out, and that should basically sum this particular thing up. Now the next version of this requires its own video that I'll probably do, because there's a lot of things going on with this, and you know, this is a completely different microcontroller. This one uses JTAG instead of ICSP and debug wire. So debugging on these larger 18 megas is just easier anyway, and just in general, because JTAG's so much faster than the debug wire. I mean, for bang the bullets on debug wire, with like a 18 mega 328 or any of the other smaller 18 megas, is like, it takes it like a good minute or so to upload the code to the microcontroller and then start it and then debug. So it's like a minute. So when you hit debug, you gotta wait a minute. Which is when you're trying to write code, you know, waiting a minute for the debugger is like waiting an eternity. So you know, especially when you're making lots of small changes trying to figure out a problem. The JTAG is like, I don't know, 15 seconds. So it's a huge improvement, debugging over JTAG versus the debug wire and ICSP. So. And that's what this is. This is debug wire and ICSP. So it takes a lot longer to debug this. So just going to the larger 18 mega is, you know, I should have done that to begin with, because I knew that I would have a lot better, you know, debugging capability as far as getting things done quicker if I did it with JTAG on the larger 18 mega. But I was trying to keep this as cheap as possible, and I was probably just trying to be too damn cheap ultimately. So out with the 328 and in with a these are 1284s, so you know, they have a lot more flash and obviously more pins. So this has JTAG, whereas the 328s, I'm pretty sure they do they have JTAG. I've never used it on a 328. I don't see it, so I'm going to say no, they don't have JTAG on them. So pretty much that's all there is, guys. Not a whole hell of a lot else happening. I'll probably try to make a video in the coming days about this when I get this to a more working state than it is now. Right now this is just a frequency counter build platform. So anyways, I know that the people are asking lots of questions about this, and you know, I'll definitely try to answer them. You know, I've gotten about a dozen emails about it. So anyway, guys, that's pretty much it. That's all for now. Thanks for watching. Take care of yourselves.